Okay, I'm going to start recording this. Um, so today we're going over the quiz review. Couple things I'd like to recommend for the quiz review. I already see people physically in front of me having notebooks out so they can take notes and write down what we're doing. If you're at home, you can do the same thing. One thing I would recommend is that when you're doing these math tests still online, that hey, you grab pencil, you grab paper. Most of your scrap work's going to be done there. I have a smart notebook file. It's blank up here. That's where I'm going to do my scrap work. This way I can share it with you at a later time. I also have Desmos up and ready to go. So, some of the work we could type in. Sometimes it just might be easiest to write it down, take a picture of your work, and upload the picture to me. So every question on the test does have the upload a picture option. So if you just want to do all your scrap work, write down on a sheet of paper and then just upload me the picture appropriate to that, that works. So go click on the quiz review, which is actually due tomorrow. The quiz is there. Okay, nobody started yet, not a big deal. Usually I will see that over here. Do they change up how they do that? Usually I can see uh, every student there, but that's fine. So you can start the quiz if you wish and work alongside with me. In fact, I'd recommend that. For the most part, I mean, if you just want to write down and then try it on your own later, that's fine as well. This is being recorded to watch at a later time. So again, you'll get 20 attempts on the review. Let's start with the first question. Find the equation of find the equation of the line that goes to these 2 points, 2 comma 6, 4 comma 3. So first thing I'm going to need to do here is find my slope. So I'm going to do my work on the smart notebook file over here. So I have the point 2 comma 6, 4 comma 3. This is problem number 1. So first thing we want to do here is find our slope. So you should feel pretty familiar with this. You guys have been doing a good job with it. So n is equal to 3 minus 6 over 4 minus 2. That is negative 3 over 2. So negative 3/2 is our slope. Now we need to find the full equation. I am going to use point slope form. If you like y equals mx plus b more and solving for b, it doesn't matter which way you do it. I'm just going to do point slope because that's one of the ways we learn and help you get a little more familiar with that. So remember, point slope says y minus y1 is equal to m times x minus x1. So what I'm going to do here is, again, this was y1 right here. This was x1, and we just solved for m. So let's put those in the appropriate spots here. So that's going to be y minus y1 is 6 is equal to m negative 2/3, or sorry, negative 3/2 times x minus, now my x1 value is 2. And then what I can do from here is I am just going to solve for y. So first thing I'm going to do is distribute. So that's going to give me y minus 6 is equal to negative 3 halves x. Two negatives will turn that to a positive. 3 halves times 2 is just 3. Finish it up by adding 6 of both sides. And we get y equals negative 3 halves x plus 6. Or no, not plus 6, plus 9. And that's it. Now, typing this all up would be a little bit of a pain. If I just read this all down on a sheet of paper, I would take my phone, take a picture, email that to myself, so that I can upload that to the quiz. So actually, I can. Yeah, I'll show the picture part later with Desmos, because that would just be faster than saving this as a picture right now. So here with this, I would upload all my work. I could attempt to type this all in. I know that's going to be a little bit of a pain, but I'm just going to type in the final answer for right now. Y equals negative 3 halves x plus 9. So if you want to put all your work in there, you can take the time to type it out. Or if you wrote it out like I did, take a picture of it, upload that picture to me using this right here. So if you click on the picture, you can upload whatever work you need to upload. Next. Okay, find the equation of this line. Very similar idea here. Very similar idea here. So this one, though, is actually a little bit easier. Okay. My SmartInk's not willing to write on the board right now, but we'll deal with that. Let me let this person in. So here with this is already my y-intercept, right? My y-intercept here is 3. Now here with this, watch this, I can count the slope. I could go down 1, right 2, that's a slope of negative 1/2. So I could actually just read this from the graph. So y equals, now my slope, again, I went down 1, right 2. So negative 1/2 x. What? Oh, okay. Negative 1/2 x. Then my y-intercept's up here 3, so I can say plus 3. And that's it. Now my y-intercept, I counted my slope. If you want to take the time to calculate your slope like you've been doing on your warm-ups or do-nows, you can. You will get the same result. Just trying to show you how we can do this a little bit faster. And here's another thing. Watch this. I can go into Desmos and type this in and just compare my graph. So I could be like, oh, y equals negative 1/2 x plus 3. Whoop. X plus 3. Let's look. Yeah, those graphs look pretty similar. Let's see. I got, yep, that one. And yeah, if I move my finger here, it looks like 2, 2 should be a point. So yeah, looks like we got it. Awesome. Okay, determine if this function is a graph or not. So this is where we're going to utilize the vertical line test. So if I were to attempt to draw vertical lines here, I'm not seeing any issues with this. There's no place on here. Oh, wait, what about here? No, it looks like at 2, there's a gap. It doesn't look like they overlap. So here with this, is this a function? I'm going to say yes. It passes the vertical line test. Well, so all I did, guys that are physically in front of me, just say it passed the vertical line test here. I just realized that might be a little harder for you guys to read. Next one is very similar. Oh, this one's going to have issues though. If we look around -2, I see it hits 1, 2, 3, 4, 5 times. This definitely fails the vertical line test if you have the value of x equals -2. Or sorry, -3 is where it hits 5 times, but -2, it also fails. At -4, it fails. We have a few different places in the area between -1 and -5 where it would fail the vertical line test. So is this a function? No, it fails the vertical line test. Vertical line test. So I don't know why my smartboard's being a little finicky and won't let me write physically on it right now. I will make sure for these two problems to do them later on Smart Notebook, move that image over there and show that vertical line test and include that as part of our work. Okay, here with this, I have f of x is equal to 3x plus 2. There are two ways to do this. We could do this all with Desmos, or we could do it by hand. I'll show you with Desmos right now. So here with this, I said f of x is equal to 3x plus 2. Okay. Then it asked me for f of 2. Well, that needs to be a new line. If I just type f of 2 like this, that's 8. F of -2 is the next one. That's -4. That's at f of x minus 3. Well, for x minus 3, it just gave me a new graph. We could look at that equation, but okay, it didn't do exactly what I wanted for f of -3. So we're going to have to do that one along with the other two by hand. So I'll show you how to do those by hand as well. Okay, this is we're on number 5. Thank you. So we have so just answer what number it was. I can number it here. F of x is equal to 3x plus 2. So when I say f of 2, all I'll do is plugging 2 in. So 3 times 2 plus 2. Well, 3 times 2 is 6 plus 2 is 8. That's like f of -2. That's going to be 3 times -2. That's -6. -6 plus 2 is -4. Now finally, f of x minus 3, where I was just plugging in 2 and -2, I'm going to plug in x minus 3. So it's going to be 3 times x minus 3 plus 2. So all I'm going to do here to start is distribute. And that will give me 3x minus 9 plus 2. gives me 3x minus 7. So my answer's 8, -4, 3x minus 7. Again, if I had taken a picture of this, I would just use the upload picture and put all my work there. I'm just going to quickly type my final answers just for time's sake. So that one we saw was 8. F of -2 was -4. And then F of x minus 3 ended up being 3x minus 7. And that's it. Oh, it was minus 7, right? No, minus 7. Okay, number 6. Very similar problem. All we're going to do is plug these in. Again, I just showed you how to do it on Desmos. I'm going to do this one by hand just because the last one's just still has that variable in it, so it's better to do by hand. Okay, g of x is equal to -x squared minus x. So, number 6, g of x is equal to -x squared minus x. For the first one, what did I want? F of 3, g of 3, g of -3, and then 2x. So g of 3, negative, then 3 squared minus 3. So 3 squared is 9, make that negative. -9 minus 3, -12. G of -3 will be negative, that in parentheses, -3 squared minus 3, or minus -3. This one I'm going to do in 2 steps here. When I square that negative, that becomes a +9. There's still a negative hanging out in front. So that is a -9. 2 negatives here make a positive. Plus 3 will give me -6. Then g of 2x be -2x squared minus 2x. Well, 2 squared will be 4. X squared is x squared. So this will now become -4x squared minus 2x. And that's it. Again, I will have these notes saved for you and uploaded for you when I upload this. So, g of 3 we found to equal -12. G of -3 equals -6. And then g of 2x is equal to -4x. I can hit caret to tell me squared, or I can use a little superscript there. I already did the caret, so it really doesn't matter. Minus 2x. Okay. Here with this, graph this piecewise function. I'm going to show you how to graph a piecewise function, get the picture of it, and upload it. If you want to do it purely through Desmos, you can. So let's see how to do that. So with a piecewise function, when I am trying to graph this using Desmos, I want to turn off my other graphs for right now. I am going to do f of x is equal to, they take the top half of the function, -2x plus 3. Now see how it says x is less than or equal or less than 2? I want to put that in parentheses behind it, or not parentheses, squiggly brackets. To get those, you can hit shift, and then it's a 2 next to P. So it said x is less than 2. Whoop. Less than 2. And there's the first part of this. Now I need to graph another part. I'm going to call that part g of x is equal to, and that is the bottom here, x minus 3. And then I need to put its domain restriction in. So squiggly bracket, x is greater than or equal to 2. X greater than equal to 2.
You put x minus 2, it's x minus 3.
Oh, x minus 3, thank you. So there we go. Oh, they even kind of meet up and make a somewhat V-shaped or absolute value looking shape. So here's what I'm going to do. There are 2 ways you can share this with me. You can hit the share and you can just copy this link here. Or you can export an image. If you want to make the lines a little thicker to see, you can. If you like them thin, whatever, it doesn't matter. You can do Zoom. You can download it. So that's what I'm going to do right now. So I have this image here. Let's open that file or folder. Okay, perfect. Okay, so now what I am going to do is just upload that using this. So, okay, file name, let's paste the location. Desmos graph 7. Upload. And now you can see over here that uploaded what I graphed on Desmos. I'm going to count that as you graphing a piecewise function. Piecewise functions are a pain to graph. So I'm going to take it that if you can figure out how to do it on Desmos, that's good enough for right now, okay? But they're not the easiest to graph. If you want to graph it by hand and upload your sketch, that's fine as well. Okay, identify the parent function and describe the transformation. So this starts as an x squared. So my parent function is quadratic. And if you want, you could even put behind it like x squared, like this. Okay, let's describe the transformations. A negative in front that reflects over the x-axis. Then this also goes, since it's a -4, remember inside the parentheses, it works in opposite. It's a -4, it actually moves right 4. And then the +2 on the end would be up 2. Again, if you want to confirm what this looks like, you're not asked to graph it, but you can check your graph using Desmos like so. Let's turn off these because I don't want to see that right now. So x squared was my parent function. We see that in green. Now I had negative parentheses x -4 squared +2. Whoop. That did not go into a new line. Cut, paste, There we go. So we see the purple does get flipped. It's also going to the right 4 and up 2. Yeah. No, you're good. You're good. Yep. Yep. I see all that in real time. Nate, which one was that you were working on? Okay. I'll make sure to get that updated for you. So here we can see that also reflected in our Desmos graph. If you want to graph it before you even describe the transformations and be like, oh, that's what it is, go ahead, be my guest. I can't tell which order you do it in. I use the graph to confirm what I said. You could look at the graph and then describe it. It doesn't matter which order you do it in. I'm just trying to iterate the point here that you can do it without even looking at the graph. Okay, well, disregard an equal sign in here, but you guys get the point. Okay, so this is a square root function because it has a square root in it. That's my parent function. And again, if you want, you can type it in. Over here, it has this math symbol. Square root's located right here. So I could say like square root of x. Okay, the 2 in front, that is going to be a vertical stretch. Okay, the +2 inside moves it to the left 2. And then left 2. And then the -5 on the end will be down 5. That's me describing it. Let's take a look on Desmos and see if I'm right. So my parent function, let's turn these 2 off, is the square root of x. The square root, if I pull up the keyboard, is down here. Square root of x, the black is my default right now. Let's see what it looks like if I do 2. Square root of, I said what, x plus 2. And then outside that, -5. So this gets stretched vertically. Notice how the red kind of goes up faster than the black. So that's how I know it gets stretched vertically. Then it goes left 2, down 5. So again, you can just see that visually. If you want to graph it first and see what it looks like visually first, and then describe it to me, again, I can't tell the difference between which way you did it. So it really doesn't matter too much. So I'm going to, I just noticed it in the chat. Johnny, are we talking about this problem right here that I just did or one before it?
Both of them.
Okay. So again, got somebody just looking to go over this a little more. So again, my parent function, I'm going to look at it. Since this has a squared on it, that tells me my parent is a quadratic function. So that's where I gained the parent from. Over here on number 9, my parent was a square root because there's a square root inside the box. If it's cubed, that will be a cubic. If an x is in a denominator, that is a rational. And if it's inside absolute values, that's going to be an absolute value function. So then remember, anything in front of the parentheses that will do one of 2 things potentially. It can reflect the graph, it can stretch or compress it. If it's negative, it reflects. If it's a number bigger than 1, it stretches. If it's a fraction, it compresses. So since this one was negative, I said reflects over the x-axis. Then when we're inside the function part, inside the parentheses, that moves it left and right. If it is a positive, it moves it to the left. If it's negative, it moves it to the right. So since this said -4, I said right 4. And then anything on the end will move it up or down. Positive moves it up, negative moves it down. So since this had +2 on the end, it moves it up 2 units. Same idea here. So this was a square root function. Since it had a 2 in front, the 2 wasn't negative, so it doesn't reflect. It only stretches. Since it has a +2 inside the parentheses with the x, or inside the square root with the x, remember, inside works backwards. Positive actually moves it to the left. And then the -5 on the end will move it down 5. So that's what we have. Again, with any problems, if you want to upload a picture, you can always just hit that. If you need to go back and review, you can always click over there, review there, but I'm finished. So that's all. I'm going to try and get these quizzes graded somewhat quickly, or quiz reviews graded quickly, so you can see like, oh, if this is an actual quiz, I would have scored an 82 or whatever it is. So I'm going to stop our recording and leave it for whatever questions you guys have.